to work out how to subtract signed numbers. Let's think back again to how we subtracted positive numbers on the number line. Let's suppose we wanted to subtract 4 minus 3 on this number line. What would we do? As we said when we were doing addition, here's 4 and here's 3. To subtract 4 minus 3, we pick 3 up, put it down backwards, starting at 4 and going backwards by 3. And of course the answer is 1, but we knew that. Let's compare this to another picture. This picture doesn't show a subtraction fact. It shows an addition fact. In particular, it shows the addition fact 4 plus negative 3 equals 1. But except that in this picture we've drawn 3 for reference, and in this picture we've drawn negative 3 for reference. The actual part of the picture that does the work is exactly the same in those two pictures, isn't it? And this second picture actually looks a little bit more natural, because we don't have to do this weird flip 3 over move that we had to do here. In fact, this is an important property of the negative numbers. Subtraction just means adding the opposite. So when we write 4 minus 3, what we mean by that is 4 plus negative 3. Now this doesn't seem super useful, right? Because this, we know what it is. We know that this is 1. This, in order to work it out, we need to say, well, these have opposite signs, so what I really want to do is subtraction. And 4 is bigger, so the answer is positive. So it's going to be positive 4 minus 3 is 1, right? In order to answer this, we actually work this out. The place where this becomes useful is if we're doing any other sort of subtraction. If we need to perform signed subtraction, we should rewrite the subtraction problem as an addition problem by adding the opposite, and then add normally. When do we need to do signed subtraction? We're performing signed subtraction if normal positive number subtraction isn't enough. So the obvious time is if one or more of our numbers is negative, but also we'll need to perform signed subtraction if we're subtracting positive numbers, but we have smaller number minus bigger number. So let's see a couple of examples where we're performing signed subtraction and how this rewrite as plus the negative move works out for us. Let's see the smaller minus bigger first, because this is kind of the weird one. Let's suppose that for some reason we want to subtract 14 minus 49. We would rewrite that as addition. Of course, 14 minus 49 isn't the same as 14 plus 49. It's 14 plus negative 49. And now these numbers have opposite signs, so we want subtraction. Ordinary subtraction, bigger minus smaller subtraction. 9 minus 4 is 5, 4 minus 1 is 3. 49, though, is bigger than 14, so the negative number's absolute value is bigger. The result should be negative. Or what if we're subtracting 2.6 minus negative 1.4? Again, first we'll rewrite as addition. 2.6 plus the opposite of negative 1.4 is positive 1.4. Oh, well, this is just positive number addition. 6 and 4 is 10. 1 and 2 is 3, and 1 is 4. 4.0. Maybe we're subtracting negative 3/4 minus 1/8. That's negative 3/4 plus negative 1/8. I think these need a common denominator, and I think it's going to be 8. 3/4 is, well, 4 times 2 is 8. 3 times 2 is 6. So that'll be negative 6/8 plus negative 1/8. We know the answer will be negative because these are both negative. We know it's going to be a number of eighths because these are both numbers of eighths. And the operation we want is addition. 6 plus 1 is 7. Why addition? Because these have the same sign. So let's see, we've done positive minus positive, positive minus negative, negative minus positive. What's left? Negative minus negative. Let's say we have negative 11 minus negative 23. That'll be negative 11 plus, the opposite of negative 23 is positive 23. These have opposite signs, so we'll want subtraction. 3 minus 1 is 2, 2 minus 1 is 1. Our answer will be some kind of 12. 23 is bigger than 11, so the answer will be positive 12. So again, we don't need to memorize a separate set of rules for doing sign subtraction. We should instead rewrite the problem as an addition problem where we add the opposite, and then just add as we would if we met the problem in the wild. The only time we don't need to do that is when we're subtracting two positive numbers, bigger minus smaller. Let me give you a few of these to try. Work each of these subtraction problems. Pause the video and try this now. Alright, well here we have positive numbers, but it's smaller minus bigger, so this is sign subtraction. We'll rewrite it. 3 plus the opposite of 7 is negative 7. Now these have opposite signs, so we want subtraction. We're thinking 7 minus 3, which is 4. 7 is bigger than 3. So since 7 is negative, our answer should be negative. 2.4 minus negative 0.31. One of our numbers is negative, so this is certainly sign subtraction. We'll rewrite it as addition. 2.4 plus the opposite of 0.31. Oh. Now these are both positive numbers that we're adding together. So the answer is going to be positive, and the operation we want is addition. 0 and 1 is 1, 4 and 3 is 7, 2 and 0 is 2. So we'll get positive 2.71. And finally, 8.5 minus 5 1/4. This is not a job for sign subtraction, right? This is two positive numbers, bigger minus smaller. So this is just ordinary positive number subtraction. To subtract the fraction part, I'm going to need a common denominator, which I think is going to be 4, right? 1/2 is 2/4. 2/4 minus 1/4, that's just 1/4 left. 2 minus 5, can't do it, gotta borrow. 12 minus 5 is 7. 7 minus nothing is 7. This is just 77 1/4. Would it have been wrong to rewrite it as adding the opposite? No, but it wouldn't really have gotten us any closer to the answer. This subtraction is still what we would have had to do, and the answer would still have been positive.